Buenas noches, fuckers. Buenas noches. So tonight, once again, it's about the moon and the gravitational pull it has on the tide. I know I said I wouldn't. How else am I going to get you up there now? Sorry. There is a bit of tension between us. It's finding out that it's not all that it was cracked up to be, and it is not going down very well. I need this board. This thing's staying up there because I haven't gotten to it yet, so I am going to do it right now. Okay? Tide. It's the speed at which I'm doing the other board, and I need this board. So let me get this out of the way, finish this post, and then I can crack on with the other board. It's the speed at which the tide comes in. So over 6 hours, 1, 2, 3, 4, 5, 6, with a 12-foot tide, this is what we would expect. First hour slowly starts to come in at 8.3% of the total of the height. You could say it's the volume, but it is the height of the tide, right? So 12 foot, 8.3%, that is 1/12, right? So that's 1/12 comes up. The second hour, it starts to pick up. That's 2/12. So that is a total of 3/12 right now, right? That's a quarter of the total of the water that's coming in, comes in the first 2 hours. And then we get to 3 and 4. This is when it flies in. It chugs along, right? 25% comes in the third hour, and the other 25% comes in the fourth hour. That is 50% of the total of the rise of the tide happens in 3 and 4 together, 50% of the total. Get to the 5th, slowly starts to taper off, and we get to the 6th, and it slows and stops. This is when we get the up to 60 minutes of slack water, up to an hour of Earth still spinning, moon still still orbiting, tide stops una hora for an hour, and then when it drops back the same way that it came. The moon, I don't think so. No. So the demo that I have been wanting to do and just didn't get round to doing it, I need to get this done and out of the way so I can right. Again, this was something that, like that observation about the drops the same way that it came in, this was how I kind of worked out the speed in my head, and this is roughly what would happen. So we have a sphere, and I've drawn 6 lines, or not 6, 5, but into 6 segments, right? Each one the hour. Now, put the ball in. It's probably dropped a little bit because of the weight, but the speed at which the tide comes in and drops, if I see the water line, if I slowly push this in at the very same speed, because of the surface area, it speeds up the rise because of the surface area between the lines. So 1 and 2, because they're low down, there's less surface area. It's about water displacement. I'm pushing down hard now because the ball's at the bottom. Oh, whoa, try letting up nice and steady. I let up nice and steady. What you'll see is it slowly goes down, and then I'm going at the same speed, but it's hard to detect right now. But it's obviously dropping a lot faster when it gets to 3 and 4. when it gets to these two, because there's so much more surface area, if you know what I mean. So that was my, it's give or take. It's hard to tell right now. But so that was just something I thought how to explain the speed at which it comes in. And it cannot be far off the mark. Right? Now I'm doing stuff over there. And that is why I need this board. So now I've got this out of the way, I can clear that board and carry on with the other side, which I will do probably tomorrow morning now. I've got to make it all sweet with La Luna. It's really stressed. It's not your fault, I said. It's not your fault. It's not taking it very well, though. All those centuries thinking that it had this power over the water, and it didn't. It knows nobody's landed on it. You can talk to it, but it didn't know. It was doing or not doing the gravity thing. It was just there. It presumed, you know. And now to find out, not good times. But it'll be all right. We're getting over it. I will be back, folks. I will be back. Stay frosty out there. Later.